I work in developer relations for AWS. Prior to joining Amazon, I worked in DevOps at a bunch of startups. So now I talk to other people about how they can do Opsy type things and make more effective container images and work with containers and all that good stuff. So this is a talk on creating effective images. Here's what we're going to cover. Pretty basic, pretty quick. Hopefully there should be something in there for all of you, whether you're advanced or a black belt or just kind of starting out. So there should be some things in there to help pretty much anyone out. So first things first, how do layers work? So this is a pretty diagram, and my clicker doesn't work. There you go. So you can tell, by the way, that when I made the diagrams myself instead of getting them from Amazon, because they're all made in PowerPoint, and they're all really crappy. So this is a semi-decent PowerPoint diagram that I made. And it's showing something pretty basic, and that's how the container layers themselves work, right? So you start off, you have your read-only layers, so that's things like the operating system. And then on top of that, you get a relatively thin, or hopefully by the end of this, it should be relatively thin, read-write layer that it has all the data that you commit and all the actions that you take when you're building your container itself. So most importantly, why do you actually care how many layers that you have? So a couple of reasons, right? So more layers mean a larger image. The larger that your image is, the longer it takes to push and pull, the longer it takes to build. It also means if you're a security conscious person, which all of us should be from the beginning, that not only does it speed up your builds and deploys, but it means you have a smaller attack surface. So the more things that you have in a package or in a container, the more things that there are to attack, right? So conversely, the least amount of things that I can include means that I have the smallest attack surface that I possibly can. Because you can't have a vulnerability in a package if the package isn't there. I love GIFs, by the way, and PowerPoint support for GIFs was great. I'm really thankful. So we talked about why we care about layers. So the next logical step here is, so how can I reduce the number of layers that I have? And this is just like kindergarten, right? I'm not sure if we call it kindergarten here, but kindergarten, little kids. So sharing is caring, right? So use a shared base image wherever it's possible. If I have 10 services that are all built on Node.js, I can write a shared image that has a lot of my common dependencies for all of my Node.js apps. I can limit the data that's written to that relatively thin read-write container layer. I can chain my run statements, which we'll talk about in a second, and we'll prevent cache misses at build for as long as possible. And we'll also talk about that in a second. I'm having clicker problems today. I'm also super jet lagged, by the way, so if I start saying words wrong, having some time zone problems, they're opposites. So the basics of building these minimal images, right? So clicker, let's go. Okay, so a Dockerfile is a series of instructions for building that image. It usually follows the same format, right? So instruction and then the argument, so run this, add this, copy this. That's all that it is. Dockerfiles are controlled by something that's really pretty important, right? This is, by the way, the official Wu-Tang font. This is really important to me. So cache rules everything around me. That's a pun. It's a bad pun. There you go. I delivered. So what this means when we're building our Docker images, right, is that we want to push off breaking that cache as long as we possibly can. So that means that when we chain our run statements, we can push that off a little bit. But so the way that caching works in Docker, and this is probably worth a whole talk on its own, but it looks at every child image, child layer going backwards, to see when it meets one that does not match. So that might mean that everything up until the run statement gets cached, and then once I've called run that first time, I break the cache, and then I build every subsequent layer after that. So it stands to reason that I want to build the smallest number of layers again each and every time. So the longer that I can put off things like calling run, the longer I can use the cache from build. So let's see if we can make one of these a little bit smaller. So we can start with a Dockerfile. This is totally fine, by the way. So this works. This is pretty much exactly what I would have done when I first got started Dockerizing some of the apps that I already had running, right? It goes from an operating system that I'm already familiar with. I've labeled it nicely. Everything's pretty organized. It feels pretty logical. This is fine. And I think that it's actually a really common kind of first step is that if you're moving from something like a monolith, right, the first thing that you start with is your operating system because you have to tell the server which operating system you want it to be. With containers, the same thing applies, but one, you don't always need that full operating system, and we'll talk about that in a second. But I basically made the closest equivalent as that I could get to a full server image. And it's fine. It works fine. it's pretty big. And if anyone here has been on PagerDuty before, what happens when you have a container image that's maybe 5 or 6 gigs? Everyone's got 5 or 6 gigs. What you don't have is then you continuously integrate and deploy your beautifully commented 6 gigabyte container image, and then you have 100 of them, and then guess what happens to all of your disk space? It's gone. And then you get woken up, and then you're confused, and you're like, not that obviously this has happened to me, did happen to me. You wake up, and all of your disk space is gone, and not just on one of your hosts, but on all of them, because you've been storing up all these images, and every time that you've pushed a new change to your development server, your production server, it's added another 6 gigs on top of the ones that you already had stored there. So this really adds up. So this is fine, but we can improve. So our first step is that we want to choose the right base. So from the stock Ubuntu image, 458 megs, switching to Alpine, which is a more minimal base image, and a Python version of that drops us down to 86.8 megs, right? So just by choosing a base that's a little bit more kind of strategically chosen for the language that I'm using, I can save myself quite a bit of space. Even better on top of that is I can choose a different distro. So I can choose one that's based on my language. I can choose one of the minimal ones. I can choose a different version. But they all get me various amounts of space increases. So I can save a little bit of space just by choosing a base that's better suited for what I'm doing. There are some caveats though, right? So in some cases, you do actually want the full OS. So you can't use something like Alpine, or you can't use a special base image. Obviously, so I use a bunch of bad examples with Ubuntu, but I really do like them. So some cases that you might want to do this: security. If you work in an environment that's not a startup, you might have compliance requirements. And also ease of development. So we'll look at a couple of examples, but if I use a package manager from Alpine, so that's APK instead of the usual Ubuntu, which would be apt-get, it's different. I don't always have the same packages. It doesn't come necessarily with all the requirements that I need to run my application. So it can be easier to go with the full OS instead of one of the more minimal ones. So going back to our beginning, so this is still fine. This is exactly what we started with. And going from my main operating system, I'm updating and then installing a bunch of packages. I'm copying over my app code. I'm running my server. So I can make a couple of small changes and then get pretty big results. So I can start off by changing my base image. I can change the order in which I copy things. So right now, I then copy first. I change my directory first because those commands aren't changing. And then I can just do my pip install after that, right? So I've kept my cache as long as possible before I broke it with my first run statement. So the fewer times that I can invalidate that cache, the smaller my images will be. So right now, I can move it so that I copy over my requirements.txt file first, because copying the file itself is not going to break the cache for me. So to recap for a second, layers represent differences in the file system. They add up really quickly, and they have really big consequences. So they're slower to build, they're slower to push, they're slower to deploy. It's not great, but unfortunately, it's an easy trap to fall into, right? Because if you're just getting started, or if you have an operating system that's your favorite, maybe you've been working with it at the server level for quite a while, it can be really kind of easy and familiar and friendly to start this way. And it's not always the most urgent problem to solve, right? Because running out of disk space a little bit faster than normal, or a build that's a little bit slower than normal, isn't that big of a deal when you're just getting started, or when you just have a couple of images. It only really starts to impact you when you're using continuous integration and continuous deployment, and you're pushing fast and furious, and very often, then these add up, and they have some pretty significant consequences for you. So some high-level best practices for Windows. I am not a magical Windows expert. I'm sure that there are some here. Those people are not me. So I have a couple of high-level ones. If you're looking for more, there's a couple people out there that are super-duper experts on this. There's a guy named Elton Stoneman that works for Docker that actually, I can make this joke now, literally wrote the book on this. So I think there's a book out there. So if you're interested in this, there's a book. A couple tips for Windows, though. You can convert over existing Windows images. There's a nice little command called convert to Dockerfile. You can convert from PhDs also. Windows, it matters a lot more about the paths that you build, right? So there's a couple directories, a couple drives that have really terrible consequences when you build them. They'll make your image extremely large. There's a pull request out there for quite a while, and I'm not sure whether it's been merged or not yet, that was explicitly forbidding you from building some of these paths. I haven't checked recently, but fingers crossed, is that something that gets merged at some point. You also want to avoid installing packages with MSI, so they're not super space efficient. It's not the same as with the Linux distributions where you can download, install, and then remove all in the same line, and that doesn't end up committing to your final image size. That doesn't work with MSI. Windows will save those files for later for you to uninstall. So remember, if you double-click on Windows, you pretty much get that shortcut to uninstall. It's like the same thing with MSI files, so they'll leave trash behind them, and you need to make sure that you either explicitly clean those up or that you install your packages a different way. But the takeaway here, right, is that once you build and run these packages, it doesn't actually matter what's inside them, right? So I can build containers for Linux, I can build them for Windows. It's the same commands. It's Docker build and Docker run. And whether I import them from something else or from an existing Windows image, or I build them from Linux from the beginning, once they're built, they're all the same. So I can use the same deployment scaffolding, the same deployment techniques. I can use those the same way regardless of what's inside the image. I think that's really powerful, right? Because it means that we have parity. Between all the different operating systems, I can kind of put those little boxes anywhere, and it doesn't really matter what's inside. And I think that's really awesome. So next up, we have Dockerfiles. So we're going to go through some good examples and some not so good examples. So starting out big, this is actually even bigger than my original example. The reason that I would have done something like this when I started also is because it's very organized. It's very neat. I put everything on its own line. I can make it look not as neat, and I can get some space back, but this is exactly why I would have done it, right? Because I would think when I'm moving from regular code, oh good, comments are nice. Adding labels to the person after me, that's nice. Not so much here, so we'll look at it. So I can make this a little bit better by combining everything into one run statement. So the same as in Bash in the command line, you do the double ampersand to connect those lines. I can combine everything in the same run statement so that it only makes a single statement instead. Saves a little bit of space because it's one layer instead of two, and the less layers we have, the smaller our final image will be. I can also switch my base, so I can move to the Alpine distribution. I can move my pip install. I could also do a custom base. So we talked about using shared base images where we could earlier. So this would be a custom one that I could make. If I had a bunch of Python services or a bunch of Node services or a bunch of Go services, I could write a custom base that had a bunch of those shared requirements. And that way, once I've downloaded that image once, my images can build on top of that. So the final image that I'm deploying and moving around frequently can be a little bit smaller. And it saves me a little bit of time because I only have to download it once. It probably updates much less frequently. And then the application containers themselves can be much more lightweight. I can also use my run statements more effectively. So this controls a bunch. I've also pinned some versions here. So that way I don't look for a new version every time. As long as I have Ruby 1.9.1, I'm done. I also have a cleanup statement at the end here, so RMRF. I'm cleaning up some of the installation files in the same statement. So the way that it works with Linux distributions is that if I update and install and then remove those list files in the same statement, those lists don't get committed to the final size of the image. I download them, I use them, and then they're gone without committing to the final size. So I can save some time that way. Switching user also adds layers. So if you have to do some installations as root and then you switch to a user like the Node user, that adds a layer every time you switch a user. So if you have a specific user for the language that you're using, either use that from your base image or switch first. So you don't want to switch back and forth, or do everything that you need to run as root before you switch to the new user if you're, for example, creating the new user. So try to limit the number of times that you switch back and forth. Avoid adding the large files straight into the container. So here's a bad way. So that's with 3 different instructions to do it. There's one that's slightly better. So that's running everything in one single run command. What I can also do, though, is I can remove the compressed version. So once I've uncompressed something and once I'm using the contents of that file, I probably don't need the zipped version anymore. So I can download it, I can run it, I can use it, and then I can remove that zipped version. And I've kept the size that I'm actually committing back to that layer even smaller than it was before. So a couple of language-specific examples. So these are kind of tools, I think, that apply to things beyond creating minimal container images, but use the right tool. So if I'm using Node and you're using Python, they don't need to be built the same way. Make sure that you're using the right tools for the job. In a lot of cases, you can use 2 images, so one to build the artifact, and then one to build from that base. Official languages can be really pretty big, right? So it's more space effective to use a minimal base like Alpine, but it's not necessarily the most efficient. You have some trade-offs, and we'll look at that. But make sure that you're using the right tool, right? So you don't always have to use the same base image. If I have a Go service and a Python service and a Node service, I can build those all in a way that's uniquely space efficient for the language that I'm using. So use the right tools that you have available to you. So first up, multi-stage builds were very thoroughly covered in the great session before this, so I'm going to skate through these a little bit faster than I would normally. But the same tips apply actually in some cases to both Go and Java, right? Which is where you can create a binary first and then copy that over. So you could use Scratch, but you can do kind of all of your heavyweight processing at the beginning and then just run only that binary from a Scratch image. This is explained probably more thoroughly in the session before me too, so I don't have to cover it that much. Scratch is a special empty Dockerfile, jet lag, Dockerfile. So you can use it to either build your own base images, or you can do a really minimal image that only runs a binary and nothing else. So here's an example of that, where I basically start my image from scratch, I copy something over, and then I just run it. It doesn't need to install anything. All it needs to do is run the binary. I included some links, by the way, so they're kind of scattered through here. So when the slide goes up, the slide deck goes up through the organizers, you can go through those links on your own time. So next up for Ruby, I like Ruby. The official Docker images for Ruby are super huge. And there's a good reason for that, right? So a lot of gems are dependent. So if I'm using one gem, there might be 6 recommended gems or 6 that you probably need if you use this gem, or other people that have used this often use this other one. So they can be really big. So you can use a more minimal base image, but it means you'll have to do a little bit of extra work. So in this one, I'm running APK update. I'm installing a bunch of packages that for the official Ruby image would probably come by default. But in this example, I have to add them myself because I'm using a more minimal base to build from. So that's one of the trade-offs that I spoke about earlier, right? Is that there's a little bit more work that goes into using a non-official one, because the official ones are designed to use with that language. So you have a lot of the things that you'll already probably need already installed for you, and it's part of what makes them big, but it's also part of what makes them efficient. So that's a trade-off that you have to kind of figure out for yourself. Next up is Node. So you can Docker ignore things the same way that you can Git ignore things. A good example of this is the npm debug log, which can be really huge and take up a lot of your space. So you can Docker ignore that as long as you're looking at your logs somewhere else. You can also cache your node modules depending on the order that you do things, which can also save you quite a bit of time, right? Because you don't need to pull the node modules every single time. You only need to do them if package.json changes. So the order here is really important, and it's another example where using your cache is really important here. So Java, we talked about some of the similarities to Go a second ago. Multi-stage builds are your friend here. I don't really need to cover multi-stage builds too much because they've been pretty thoroughly looked at. But I can do these in 2 steps, which is basically summary. I'm building an artifact, and then I'm using the result of that in the next stage. It means my final image is super minimal. This is especially good if you're using something like Maven to build your Java applications. This can save you quite a bit of space because you do all of your heavyweight building and processing first, and then you move on to that minimal final image. Here's another example of multi-stage builds, but you guys have already covered this, so I'm not going to look at this one because I think the session before me was much better. So we're going to ignore this, and we're going to move on. So a couple of things I think to look at, because not everyone wants to do these kind of themselves by hand. So how can all of us do less work? I'm pretty sure that this is something called thought leadership, so everybody's welcome. So how can we all do less work? And the best answer for this, I think, is tools. And it's not just about Docker images, it's for pretty much everything else. That's why we have orchestration tools, that's why we have image scanning tools, that's why we have other people's cool CLI projects, that's why we have open source communities. So you have to keep a couple things in mind. So security, scalability, resiliency. So as long as you're building with those in mind, you can lean on tools to help you spend a lot less time kind of fiddling with bits that aren't related to you, and then you can focus on just building your application. And I had a customer that put this a really nice way to me. So he worked in the foreign currency, so the currency exchange business. And he said that anything that's not directly related to selling foreign currency is not something that I really want to worry about. And I think that it's an attitude that's shared by a lot of people, right? Is that they just kind of want stuff to work. So once they've gotten a good system for building and making these minimal images and making things secure and safe and resilient, they just kind of want things to work. And a really good way to do this in a lot of cases is tools. Because if you're working on a problem, chances are someone else out there has worked on the same problem. And maybe they've spent a lot of time on it. Maybe they've already figured out a really great way to deal with it. So definitely lean on the tools, definitely lean on the ecosystem, definitely lean on the whole community to help you solve all these problems, right? Because you don't have to do anything in a vacuum. So I think one of the kind of best known tools that we can use here is image scanning. So I think something that comes up with Docker containers, a lot of security, and how do I make sure that I'm using images that I trust. So there's security scan, which is from Docker, which you can use with trusted registry. There's also a really new one, I think it was like 2 weeks ago from Aqua Security that's really cool, continuous image assurance. There's an open source one called Claire from CoreOS. They're all focused on a similar problem, right? Which is, how do I make sure that I'm trusting the images that I'm running? So the same way that like most of us try not to download strange packages from the internet, run them places, you want to make sure that you're not doing this too. So look for vulnerabilities, look for packages that are unsafe, and you can use these tools to help you make sure that the images that you're running and downloading and using are coming from a safe place. You also want to clean up after yourself. So beyond just kind of making these minimal images, that doesn't really help you with the whole problem, right? So Docker leaves behind extras, so untagged images and volumes and things like that. So you want to be cleaning up after yourself. So you can use 2 Docker built-in commands. So one of those is image prune. That will clean up all untagged images. You can go further with system prune, which will do untagged volumes. These are good things to run pretty frequently. It helps you keep your space pretty lean. On top of that, though, I think something that's important for everyone is garbage collection. So beyond kind of system prune and image prune, you want to clean up everything else. So most orchestration platforms, so ECS or Kubernetes or whatever you're using, they will have some built-in garbage collection. If you want to garbage collect on top of that, there's also a bunch of third-party options out there. I used one from Spotify called Spotify GC, and I basically ran that as a container all the time, and it collected untagged, unused images. It went back a little bit more aggressively than the built-in ECS garbage collection, so it helped me keep my disk space really low. Not included in this talk, but once we're on the subject of disk space, which is apparently one of my favorite topics next to port allocation, because I like to talk about all the uncool things, you can do the same thing with your logs, right? So most distributions have a version of log rotate that cleans up logs probably once every 24 hours. Once you get into something like continuous deployment, you end up creating a lot more logs, right? Because you have the agent logs, you have processes running on your host that have logs. So you can also log rotate more efficiently too, to clean up these logs more frequently and rotate extra files so that you can keep the space on your host pretty low. So wrapping up, since I have promised to be exactly on time. So what did we learn? So if you took one takeaway out of this, it's that less layers is more, right? So share the layers where possible, use these base images where possible, choose your base wisely. So it's a trade-off between using an image that's designed for your language, so like the official Ruby image or a Python image, versus either building your own or using a shared base image, or you're using a minimal one and installing only the packages that you need. Use the right tools. So not every language needs to build the same. Your Go container should build differently than a Java container or your Python container or your Node container. You can keep it simple and avoid the extras. So a lot of package managers will have things like install recommends. So that installs kind of all the packages that it thinks you probably want. So a big candidate of this is build essential. So who here has tried to install something and then found out 15 minutes later that secretly everything was relies on build essential, right? So install recommends does things like build essential. So all those kind of extra things that you don't really think about, make sure that you have those for you, but you can also explicitly install only what you need, and then lean on tools because they're here to help you. I have some useful links in here. So if you're looking at this deck on your own later on, you should be able to look at these. I included things on like Scratch and the image documentation, some more language-specific things on Java or some Windows-specific examples, and then any open source tool that I used, I've made sure that I linked in this as well. So thank you, and enjoy the rest of Container Camp.